Hello friends, welcome to CEC live lectures. Dear friends, today in this session we are going to continue further in our series on computer networking. Today we are going to talk on network components, and for this discussion we have with us in our studios Dr. Pavitra Bharadwaj. Dr. Pavitra Bharadwaj is Assistant Professor in Department of Computer Sciences, Jesus and Mary College, University of Delhi. Dr. Bharadwaj is a prolific as well as a dynamic professor who believes in giving most of her knowledge to the students. She believes in sharing her knowledge. Friends, if you want to ask questions from Dr. Bharadwaj, then you can call us through our toll-free number. Our number is 1800-110-430. I repeat, our number is 1800-110-430. All dear friends are requested to call in the last 10 minutes of the lecture so that first you could have the deep insight into today's session, and afterwards we promise to give answers to your questions through Dr. Pavitra Bharadwaj. Dear friends, now we would like to welcome our guest Dr. Bharadwaj once again so that we could continue our lecture further. Hello ma'am, welcome to the lecture.
Thank you, Katina. Good afternoon. In continuation with the ongoing lectures on computer networking, today we are going to talk about network components. So we have been discussing about what are networks, how networks are modeled. So we are all familiar with that a computer network is basically an interconnection of computers for the purpose of resource and information sharing and communication. Now it is composed of basically two components. One is the hardware component and the other are the software component. So whenever communication takes place, there is always a sender of the information, there is a receiver of the information, then the information passes through some carrier or some medium, then there are some protocols which govern the way information is passing from one sender to the receiver, and the message itself is composed of some data and other information. Now we have also seen that we have networks of different types, like we have smaller networks which are called the local area networks, we have the wide area networks, and we have the metropolitan area networks. Now we also understand that networks are of various sizes and there are requirements for joining or expanding the networks. For instance, in an institution, if we have a networked computer lab which has say about 20 computers, but as the number or the demand for the lab increases, we need to increase the size of the lab and we need to add some more computers to the lab. Now in this situation, what we need to do is that we need to expand the lab, expand the local area network which has been created. Now in order to expand this local area network, there are two ways. One is that you add more computers and you simply join them with wires, with the existing transmission wires that are there. But this approach can be a little ineffective because in the long run it is not going to give you the desired outputs in terms of speed, in terms of quality of service, in terms of delivery. Therefore, there comes the need for some other hardware devices which are to be connected to the network. Now these devices are specific hardware components which are used for two purposes. Basically, one is for expanding the existing LANs or the existing networks, and the other is for remote access. That is, if you want to access a computer network which is not in your local domain, which is not geographically situated in your neighborhood or in your purview, then you need another kind of devices. So basically, network components are required for expanding the local area network. Now there are different types of networking components. So in today's lecture, we are going to discuss about all these different types of networking components which are there, which are used commonly for both the purposes of providing remote access as well as for expanding the local area network which is there in the computers. So now we will begin with our lecture. So we have seen that the OSI model has 7 layers. The OSI model shows how network communication will take place. Now these are the 7 layers of the OSI model, which are composed of application layer, presentation, session, transport, network, data link and physical layer. Now we have seen in the last lecture, we had seen how communication is affected and how communication takes place across all these 7 different layers. Now at each layer the message passes, some headers information is added to it, and at the receiving end the opposite or the complementary action will take place. That is, the headers which are added at the session layer of the sender will be removed at the session layer of the receiver. Now what we are going to see in this particular lecture is that at each of these layers of the OSI model, we put specific devices. So each of the layer has its own device, its own hardware devices which will work on the data packets or frames or the data signal perhaps, which is going to pass through this particular layer. So we have devices which work specifically at each given layer. So now we are going to see what are the different types of networking devices that we are going to see today. Now we have the first device is the repeaters, then we will be talking about the bridge, the switch, then the routers and the gateways. So each of these devices, they work at a different layer in the OSI model. Now this slide shows basically where each of these devices work. So we can see that the repeater or the hub, it works at the physical layer. The bridge basically works at the data link as well as physical. The router works at the network layer, and the gateways, they work at the application layer level of the OSI model. So basically in this case what happens is that the physical layer is basically of the physical layer of the OSI model is basically dealing with the transmission of the electromagnetic signal over the basic physical transmission media. So in this case we will look at the devices like the repeater and the hub. Their work will only be to just add or to attenuate an existing network. Similarly, we will see other devices, and the highest device which works at the highest layer, that is the application layer device, that is the gateway. The gateway is actually we are going to see that how a gateway uses protocol conversion to pass on the message from the receiver to the sender effectively. So the two functions of networking devices are expanding a network, that is to connect the different local area networks or to divide a large local area network into smaller local area networks, and the second is the remote access. So we see that a repeater, a bridge, a switch, a router and a gateway, they are working for expanding a network, and a modem is a device which provides remote access to a computer which is connected to it. So the first category of the devices that we are going to talk about is a modem. Now what is modulation? The first important thing to understand is the concept of modulation. Modulation basically means adding the electromagnetic signal to a carrier wave. Now what is a carrier wave? A carrier wave is a single frequency simple sinusoid wave, sine wave, and onto that wave, onto this carrier wave, signals are added. The data which is to be transported is added in the form of electromagnetic signals on the carrier wave. So this carrier wave, these signals can be added to the carrier wave by modulating one or more of the carrier's 3 characteristics. So the first characteristic is amplitude, second is frequency, and the third is phase. So any of the three attributes of the carrier wave are changed so that it can carry the electromagnetic data on it. Now out of the three, the amplitude modulation is the simplest and the easily done. Amplitude modulation means that the amplitude of the carrier wave will change when the electromagnetic signal is superimposed on the carrier wave. Now demodulation means that the data from the carrier wave is removed and the data is obtained by the receiving computer. So basically, what is the problem? The problem lies in that the computer processes the data in a digital format, whereas the data traverses on the transmission media in the form of analog signals. We all understand that most of the data transfer take place through telephone lines. All the internet connectivity, all other connectivity is in the form of analog signals. So there is always a need for conversion of digital data from a computer into analog signals so that it can be easily transported on the transmission media, and when the data reaches the receiver, it needs again to be converted from the analog form to the digital form. So this conversion from digital form to analog form is known as modulation, and that from the digital analog form to the digital form is known as demodulation. So a modem is basically a device which performs these two functions. Modem stands for modulation and dem stands for demodulation. So a modulator and demodulator put together forms a device which is known as a modem. So it allows computers to communicate over a network using analog signals. So it enables computer networks to transfer data through telephone lines and other analog channels which carry the data and to connect the LAN to the wide area network. So a modem is a computer peripheral that allows us to connect and communicate with other computers via telephone lines. It is a communication device that converts binary signal into analog signal for transmission over the telephone line, and these analog signals are converted back into the binary signals when they reach the receiving end. So this diagram actually shows the working of a modem, how a digital signal from a computer passes to the modem and is converted into an analog signal. This analog signal is traversed on the public telephone network. It reaches the receiver, where the receiver's modem transfers the analog signals and provides it in the form of a digital signal. So this is basically the work of a modem. Now the next important component of connecting a computer to a network is the network interface card or the network interface adapter. So a network interface card is basically, this is the diagram which shows a network interface card, that is how a computer is going to connect to the network, what interface it is going to use. So basically a network interface card is a piece of computer hardware which is designed to allow computers to communicate over a computer network. Interface between a computer and a network is provided by a network interface card. So computers that are part of Ethernet install a special card called the Ethernet card. So basically an Ethernet card supports three types of connections. One is the RJ45 connections for the networks of twisted pair, BNC connections for coaxial cables, and the AUI connector for the other types of network. So a network adapter basically has a unique address which is 16-bit long hexadecimal address, and this address is known as a MAC address. MAC address stands for Media Access Control Address. So this is actually hard coded by the manufacturer of the network adapter. So this address is a unique address which provides a unique identity to all computers on the network. In case you want to know the MAC address of your computer, so in the Windows computer you can go to the command prompt and type the get MAC command. So this is going to give you the MAC address of your computer's network interface card. So basically the MAC address is the physical address of the computer on the network. So the network interface card is providing the interface for a computer to connect through various mediums like the coaxial cable or the twisted pair or through wireless. A computer can also be connected to wireless media if it has the wireless access controller installed on it. The next device that we are going to talk about is the repeater. Now a repeater is very important. When signals leave a transmitting station, they are clean and easily recognizable. However, the longer the cable length, the weaker and more deteriorated the signals become as they pass along the networking media. Repeaters can be installed along the way to ensure that data packets reach the destination. A repeater repeats, transmits and amplifies the bits it receives. It extends the span of a single LAN. So basically a repeater's job is to take in the signals from one portion of the LAN and regenerate them and amplify them and forward them to the other portions of the LAN. So this diagram shows how a repeater works. You can see here that there are two components of the LAN which are joined together by a repeater. So a repeater connects two segments of the local area network, and a repeater, as you can see, it works at the physical layer of the OSI model. So basically a repeater is not an intelligent device. It will only do the process of forwarding the packets which come from different segments of the LAN. So it forwards every frame as it receives it. It is a regenerator, not an amplifier. It is used to create the single extended LAN. So it can't filter network traffic. Data, sometimes referred to as bits arriving at one port of the repeater, gets sent out on all other ports. Data gets passed along by a repeater to all other LAN segments of a network, regardless of whether it needs to go there or not. If any two nodes on any two connected segments transmit at the same time, collision will happen. So therefore we say that a repeater is not an intelligent device. It will just take in the packet coming from one segment of the LAN. It will not verify the contents of the LAN because of the packet, because it is actually treating the packets, it is reading the bits and not frames. So it will just amplify those, it will regenerate the signal and it will pass on that to the other segment of the LAN. So therefore if the packet or if the bits have some error, then also it is going to transfer, it is going to forward those errors to the other part of the LAN. Sometimes it happens that the two hosts on the same segment of the LAN, they start transmitting data through the same transmission media. In this case, collisions may occur, but repeaters are not designed to handle these collisions also. Their simple job is to accept one packet or some bits from one portion of the LAN and forward them to the other. The only job is to send a clean signal from one part of the LAN to the other part of the LAN. They do not look at the contents of the bytes which are being sent, whether they are the correct data or it is an error data. So you can see here in this diagram also that the repeater accepts a corrupted signal and it gives a regenerated signal. So we have two types of transmission, left to right transmission and right to left transmission, which is done by a repeater. The next device that we are going to talk about is a hub. A hub is a hardware device which is used to connect several computers together. A hub contains multiple ports. So basically a hub is a multi-port repeater. It is not aware of the transmitter or the receiver. It broadcasts the packets to all the ports, including the source. Hubs forward any data packets, including email, etc., without looking at what the data is to all the ports. All users connected to a single hub are in the same segment. Hubs are either passive or active hubs. So a hub is basically a multi-port repeater which will accept the packet and it will forward it to the other segment. Now hubs, as we said, are of two types, active hubs and passive hubs. So active hubs, they electrically amplify the signal as they move from one connected device to the other, and passive hubs, they allow signals to change from one computer to the other without any change. So they are not even going to amplify the signal which they are receiving. So a hub basically receives bytes of information from one segment and they pass it on to the other. Hubs also are a physical layer device, so they work at the physical layer of the OSI model. So when the hub receives a data packet from any of the LAN, it just does not do any kind of filtering and it copies the frame into all the other links. So the entire hubs forms a single collision domain and a single broadcast domain. Now what is a collision domain? Is that part of the network when two or more nodes transmit at the same time, collision will happen. And broadcast domain means that part of the network where each network interface card can see other network interface cards' traffic, broadcast messages. So multiple hubs can be used to extend the network length. So what happens is that in case of local area networks, there are some segments of the networks where collision may happen and there are other segments on the network where collision may not happen. So the segments of the network where there are chances of a collision to happen, they are known as a collision domain. And the other type of domain is known as the broadcast domain. In case of broadcast domain, every interface card, every computers or devices interface card can see what the other NIC is sending. The broadcast messages can be sent. So in this case, the hubs can be they have a single collision domain and they have a single broadcast domain. So a hub's job is basically to accept data from one terminal or one host and forward it to all the other hosts on the network. Now what is basically the relationship between a hub and a repeater? A hub is actually a multi-port repeater. It cannot link unlike segments. They cannot join segments with different access methods. Do not isolate and filter packets. They can connect different types of media, and the most economic way of expanding networks is the use of hubs and repeaters. But the hubs and repeaters, they also have some difference amongst them, like the hubs are different because they provide network management features by gathering information about the network and report them to a monitoring host connected to the hub. So some statistics about the network like bandwidth usage, collision rates, average frame size can be generated. If an adapter is not working, the hub can disconnect it internally and network will not be affected. So basically a hub, we say, is a multi-port repeater, but a hub is still a more sophisticated device than a simple repeater. A repeater is a more primitive kind of device because a hub, you can connect a hub to a host and still the hub can gather some information about the type of traffic which is there on the network, and you can use that host to gather some kind of network related information. Although both hub and repeater do not have any kind of packet filtering feature in them. So the next device is going to be a bridge. As we know, what is a bridge? A bridge generally joins two ends of a river maybe, right? So in this case also, a bridge is a device which is going to join two segments of the LAN. But a bridge, then what is the difference between a bridge and a hub or a repeater? So bridge basically acts on the data link layer. Acting on the data link layer means that it is used to divide the segments, the LAN, into smaller LAN segments, or to connect LANs that use similar or dissimilar physical and data link layer protocol. Each LAN segment is a separate collision domain. Bridge does not send the received frame to all other interfaces like hubs and repeaters, but it performs filtering. Filtering means that when a frame should be forwarded to another interface, that leads to the destination, or it is dropped. This is done by a bridge table, which is also called as a forwarding table, that contains entries for the nodes of the LAN. A bridge table is initially empty and filled automatically by learning from frame movements in the network. A bridge runs the CSMA CD before sending a frame onto the link, not like a hub or a repeater. Bridge frame handling is done in software. So we have seen that in case of bridges, a bridge is a more sophisticated device because we have some kind of software encoded in it which controls a lot of functionality like packet filtering, collision detection and media access, which is not provided by the hub or the repeater. A bridge filters the packets. It has some kind of filtering and forwarding mechanism in the form of a bridge table or a forwarding table that contains entries on the nodes of the LAN. So we shall be continuing with the bridges in a short while.
With this note, thank you, ma'am. Thank you so very much. And dear friends, we would like to tell you all that we are with you after a short break. So be with us. Be with us. Hello friends, welcome back to this session where we are discussing on components of the network, that is the networking components, and for this discussion we have with us Dr. Pavitra Bharadwaj. So I would like to request Dr. Bharadwaj to continue further, and as in the previous session we told you that we are going to continue further from the bridges and we would be talking on bridges, so I request ma'am to continue.
So we were talking about how bridges are different from a repeater and a hub. So we understand that a bridge is basically an intelligent device which connects two segments of the LAN, and these two segments, they lie on a separate collision domain. Collision domain, as I said earlier also, is basically those network interfaces which can send the packets at the same time, and collision can occur on those segments of the local area network. So in case of bridges, there is the two LANs, they lie on separate collision domain. Then bridges, they maintain a bridge table or a forwarding table. So basically what they are going to do is that when they receive a packet, they will look at the contents of the destination and they will forward that packet only to the destination host, unlike the hubs and repeaters which will forward the packet to all the hosts. So in case of bridges, flooding will not happen most of the time. There is specific situations in which the bridge will also flood the traffic, the packets on all the hosts, but otherwise a bridge can do packet filtering. That is, it can judge that which packet is to be sent to which particular host, so that it is not unnecessarily utilizing the bandwidth by sending the packets to unwarranted hosts. So we can see that how a bridge is working here. So we have these two segments of LAN. These LAN segments, they can be of different, they can be dissimilar LAN segments which are using dissimilar technologies, and a bridge can connect these two LAN segments. Now this diagram shows how a bridge works as compared to a hub. In case of a hub, you can see that if a packet is to be sent from a particular host to another host, in that case also the hub will forward the packet to all other hosts which are connected to it. But in the case of a switch or a bridge, when a packet is sent from a host F to a host C, it is only sent to that particular host and to no other host on the network. So a bridge basically maintains a forwarding table, as you can see in this diagram, that on the two LANs, on the two segments of the LAN, each host has its address, and the routing table or the forwarding table that a bridge has, it keeps the address of each host on the segment, and it also keeps the interface to which the hosts are connected. So this table is known as a bridge table. So whenever it will receive a packet on any interface, it can check on which other interface the packet is to be forwarded, because it keeps a record of all the packets which are received from one port. So if a host A is on the interface 2 of the bridge, then all the packets which are received for the host A will be routed to the interface 2 and not to the other interface. Now bridges, therefore, they work very efficiently in case of managing traffic on simple LAN conditions. So there are two types of bridges that we generally see. The first type of bridges are known as transparent bridges, and the second type of bridges are known as source routing bridges. So transparent bridges are those bridges which are not known by the hosts on the network. Now these transparent bridges, they have two ways of working. First is that they use bridge forwarding, and the second is that they use bridge learning, that is learning to create a forwarding table. In case of bridge forwarding, what happens is that the bridge creates the forwarding table beforehand, and then the packets are routed to any of the interfaces to which the bridge is connected. In case of learning to create a forwarding table, initially when the bridge is connected, the forwarding table is blank. After that, when the packets are sent, the bridge starts building up its forwarding table, and it then builds up the forwarding table so that in the future when any more packets are coming, then it can refer to this forwarding table and forward the packets on it. The second type of bridge that we discuss is a source routing bridge. A source routing bridge basically is a bridge where routing operation is performed by the source host. So the host sends discovery frames. It provides the shortest path, but rapid increase in the discovery frames happens. So what happens in case of source routing bridges, that each bridge, each source which wants to send a network, a packet to the network or to another host, it will first send some frames on the network. These frames are known as discovery frames because these frames are broadcast to all the hosts on the network. The bridge will broadcast these frames to all the hosts on the network. Now, these frames, they traverse to all the hosts. The destination host will then revert back. The other hosts who will receive this discovery frame they may discard these frames, but the destination may revert back with its address back to the host who had sent the discovery frame. So therefore, the sender will know the shortest path to reach the destination. But in this case, a lot of network resources are utilized or they are wasted because the discovery frames which are traversed on the network, they create a lot of traffic unnecessarily on the network. Because each host, before sending any kind of data onto the network, will first send a host of discovery frames to all the hosts. Therefore, there is a lot of cost involved in this case. Thus, the transparent bridges which have a forwarding table are considered to be more efficient in terms of bandwidth usage than the source routing bridges who will work on the shortest route. Although the forwarding will take place through the shortest route, therefore, it will be faster in case of source routing bridges than in case of transparent bridges. Now, another device which is very similar in its functioning is known as a switch. Actually, a switch is again a multi-port bridge. So, a switch is higher in sophistication than a simple bridge, but both of the switch and the bridge, they are a layer 2 device. That is, they both work at the data link layer of the OSI model. Therefore, they both deal in frames. This can interpret address information and they are considered as multi-port bridges. They have multi-ports, but they can better use limited bandwidth and prove more cost effective than a bridge. So, what does a switch do basically? It divides a network into several isolated channels. The packet sending from one channel will not go to another if it is not specified. Each channel has its own capacity and need not be shared with other channels. So, as you can see in this diagram, we have a switch which gets a 10 Mbps speed. This 10 Mbps speed is given to the hub, and this is then divided into the 3 hosts equally. So, the bandwidth which is divided is equally divided into all the hosts which are connected. So, this kind of architecture is very important when a large number of hosts are connected and each of these are doing a data intensive task, maybe like video conferencing, etc. So, in that case, a switch proves to be a very important and economical device. Now, the switch also has its mechanism of building its switch table. So, when a switch receives a frame, it compares the source address of the frame with each entry in the forwarding table. If no match is found, the bridge will add to the table the frame source address and interface on which the frame was received. If a match is found, then in that case, the packet will be forwarded to the interface on which the frame was found. So this way a switch, it learns by working. So when initially a switch is connected, it is blank, the forwarding table is blank. The first time it gets a packet, it notes down the interface from which the packet was received, and it also notes down the interface to which the packet was sent. So the frame is different from one table, it also updates and also records the time. So then the switch compares the destination address of the frame with each entry in the forwarding table. If a match is found, the bridge compares the interface number on which the frame was received and the interface number in the table. If they are different, the bridge forwards the frame through the interface number stored in the table. Otherwise, if they are the same, the switches discard the frame. If no match is found, the switch floods the frame on all interfaces except the one on which the frame was received. So in this case, what we understand is that a switch will flood only in case where no match is found. In case there is some problem in the destination address, the switch will decide to discard the packet. It will note the interface of the destination and it will also note the interface of the source. So if the source and the source interface and the destination interface, match is found, then it looks for the MAC address of the sender and the receiver in the forwarding table. If this match is found, it forwards the packet, otherwise it will decide to discard the packet. In case of a learning switch table, it will try to build the switch table or the forwarding table with the data packets that it receives. So we can see in this diagram, this shows how a switch learns and how the process of forwarding takes place with the help of a forwarding table. So initially we can see that the forwarding table is blank, that is both the address and the port are blank. When A sends a frame to B, it notes the address of A and it notes the interface at which the packet was received, that is it notes 1. Then E sends a frame to A, so it notes the address of E and also notes the interface at which E is connected. After B sends a frame to C, it will note both B as well as C. So when it will see that a packet has been received with no destination address, then it will flood all the interfaces of the local area network with the packet, and but still it will not forward or it will not flood the same interface from which the packet had been arrived, assuming that the source and the destination may not be on the same interface of the bridge. Now a bridge has several advantages than other devices that we have discussed. First, it carries on an intelligent packet filtering. It deals with collisions a lot. Very effectively it deals with collisions in case of data, because it only sends the packets to the destination host, to the interfaces on which the destination host may lie. In case it thinks that there is going to be a collision, in that case it will discard the packet. If the destination address is not specific, then the packet may be discarded. Therefore, switches are very intelligent because they use the CSMA-CD algorithm for collision management and getting the collisions away from the possibility of collision is reduced. Each channel has its own network capacity, so it is very good for real-time applications, and data is isolated, hence a lot of security is maintained. However, there are some limitations also. That device cannot detect collision when the buffer is full. Therefore, after that the collisions may take place. Some higher level protocols do not detect any errors. Those data packets are continuously pumped to the switch and they introduce more problems. So, there are two methods in which switching can take place. One kind of switching is called the cut through switching. Now, in case of cut through switching, what happens is that when a switch receives a packet, it will only examine its first few bits. It will not look for any kind of errors in the packet which it has received, in the frame which it has received. Thus, what happens is that the switch is going to forward a packet or a frame even if there are errors in it. So, it propagates the corrupt packets into the network, and therefore, it becomes it is not very suitable for large network. It can be used for simpler and smaller work groups. The other type of switching is store and forward switching. In case of store and forward switching, what happens is that a switch not just examines the address of the source and the destination, but it also detects any kinds of errors which are there in the frame or the packet. Therefore, in this kind, the corrupt packets will not be propagated on the network, and the network will be the traffic on the network can easily be managed, because corrupt packets will not be pumped into the network again and again, as we discussed in the case of the other type of switching mechanism, that is the cut through switching mechanism. So, it facilitates transfer between segments of data with a better speed. So, if we try to compare a switch and a hub, it is quite easy to compare the two. The first is that a hub works at the physical layer of the OSI model, whereas a switch, it works at the data link layer. A hub does not do any kind of packet filtering, whereas a switch does intelligent packet filtering. Then a hub also does not manage or maintain or look into the collision factor of the packets, whereas a switch is intelligent and it transmits only the packets to the intended receiver. Switches are of course more expensive and sophisticated than hubs. Minimal wastage is there and optimal utilization of bandwidth in switches. It provides better network security, and the switches, they work in full duplex mode rather than half duplex mode. The switches, they work in full duplex mode. So, basically full duplex and half duplex, the difference between the two is that in case of full duplex mode, the sender and the receiver can both send their data simultaneously on the network, whereas in case of half duplex mode, either the sender or the receiver can have the control of the transmission channel at any given point of time. So, in case of hubs, it is half duplex, means that if a channel is utilized by one host for sending its data, then at the same time no other host can use the same channel for sending its data. Whereas because switches are intelligent device and they have inbuilt mechanism, then these switches, they prevent collisions, and therefore they can easily afford to have full duplex mode of data communication over the networks. Now we come to a very sophisticated and intelligent device which is very commonly used in case of connecting networks to external internets also, not just segments of LAN, but different types of networks can be connected which use different kinds of media technology to communicate, to connect to each other, and these devices are known as the router. Now, a router is a very important device which works at the network link layer of a OSI model. Therefore, a router deals with data packet. So, when a packet is received, router reads the destination IP address of the received packet. It looks for the path to reach the destination address, and it sends the packet to the destination through the shortest possible path. So, a router basically has four components: input port, which holds the packet before forwarding them to the switching fabric; output port, which does the same function as the input port, but the order is reverse. that is, it will hold the packet once it has been forwarded from the switching fabric. Then the routing processor, which performs routing the network layer functions like table lookup, etc., and the switching fabric, which moves the packets from input queue to output queue through the specialized mechanism. So, a router is basically composed of 4 parts. All these 4 parts, they have their specific function. The routing processor, basically it has a routing table. Now, what is a routing table? A routing table is a logical connection which keeps a record of all hosts which are present on the network and the path from each host to the other host in terms of number of hops. That is, how many hops are required to reach one host from the other host in a given possible time. Therefore, a router will not just route the packet from the source to the destination, but it will also route the packet through the shortest possible route. So, it maintains the shortest path from each host to the other host in its routing table. Then it does one more important part, is that a router is connected to a number of other routers on the network, and at regular intervals of time it will broadcast its routing table to all other routers on the network. So, the other routers on the network will also keep updated of their routing tables according to this table. So, it basically, a router operates at the network layer. It deals with packets and not frames. It connects local area networks and wide area networks with similar or different protocols together. Switches and bridges isolate collision domains but forward broadcast messages to all LANs connected to them. Routers isolate both collision domains and broadcast domains. Acts like normal stations on a network but have more than one network address, that is an address for each connected network. So, a router is not just keeping the physical address or the MAC address, but each router has its logical address also, which is commonly known as the IP address of the router. So, a router's identity is not with the MAC address, but it is with the logical address of the host on which it is kept. So, it forwards all information to the destination host which is available, or it discards it, and not like a switch or a bridge. So, it has routing algorithm which are special software installed on them, and they use these routing algorithms to communicate with each other, and all routers, they keep exchanging their routing information with each other. So, a router basically works at the network layer. So, it deals with packet filtering, it deals with how the packets are securely dropped, and it also maintains the different kinds of connections. So, this diagram here, it shows how routers are connected to independent LANs, WANs, and to the rest of the internet. So, routers can be used to connect either local area networks or wide area networks and local area networks together. Now, routing table is formed on the basis of communication between the different hosts on the on the network, or different routers which are using routing protocol. Now, routing protocols, they collect data about current network status and contribute to the selection of the best path. So, in this case we can see that the routers, they communicate with each other and they keep the shortest path in a table which is known as the routing table. So, they keep the destination, the adjacent router, and the number of hops which will be required to reach the destination router. So, a router and a bridge and a switch, they are both intelligent devices, but still a router is much more preferred than a simple switch, because a router is a more sophisticated device which is dedicated for the function of forwarding packets through the shortest path on the network. Therefore, a router can be implemented on a simple host computer, or there can be dedicated routers which are utilized for efficiently managing the networks. Routers again are of two types: static routers and dynamic routers. Static routers, they have manual configuration of routes, but the dynamic routers, they have manual configuration of the first route, then after that automatically they discover the new routes. Static routers always use the same route. Dynamic routers, they select the best route. Static routers are more secure, but dynamic routers, they need manual configuration to improve their security. Therefore, static routers may sometimes be preferred, but given the situation, the decision is taken whether static routers should be preferred or the dynamic routers should be preferred. The last device in this series is going to be the gateways. Now, gateways are commonly known as protocol converters because they make communication between different architectures and environments possible. They repackage and convert data going from one environment to the other so that each environment can understand the other environment's data. So, a gateway repackages the information to match the requirements of the destination system. Gateways can change the format of a message so that it will conform to the application program at the receiving end of the transfer. A gateway links two systems that do not use the same protocols or data formatting structure or language or architecture. So, basically gateways will work at two systems at the application layer level. For example, if we have an email message which is passed from one host to the other, then the gateway will look into the aspect of formatting the email in such a way that the two systems which are using different kinds of email formats can still exchange their information. Therefore, gateways are used, they are generally called as protocol converters. Therefore, dear friends, with this we have completed the different types of networking components, hardware components which are attached to the networks, that is repeaters, bridges, switches, routers and gateways. With this we come to an end of this lecture. Thank you.
Thank you, ma'am. Thank you so very much for giving us a precious session. And friends, if you want to give a feedback for this particular lecture, then do write to us at info.cec@nic.in. Your feedback, suggestions are all welcome. We would be meeting again. Till then, take care. Goodbye. Thank you, ma'am. Thank you once again.